Welcome to this Kubernetes security presentation, mostly focusing on intrusion detection and mitigation. The idea of the talk and the demos is to essentially show you that it can be quite challenging to detect intrusions and mitigate threats inside of Kubernetes clusters. Demos will be mostly around how you can actually visualize it using Calico and Calico Enterprise. Just to give you an idea about the complexity and how we solve that here at Tagira. If you have any questions, feel free to put them in the chat window. I will pause regularly and see if there are any questions. If not, we'll try to answer them at the end. So I also want to introduce my colleague Jane. She's also on the call. She's responsible for EMEA, as well as I am from a technical point of view. So enjoy the talk. Any feedback is welcome, so do not hesitate. So myself, I'm a solution architect, so I'm a techie. My background is mostly in networking, load balancing, and security. And one of my big hobbies is hacking. I'm mostly hacking containers and networking stuff. So feel free to check us out on LinkedIn or Twitter. So for today, I'll brainstorm a little bit about Kubernetes, how to look at it, what a threat matrix is. And in the second part of the presentation, we'll focus on what and how Calico, as well as Calico Enterprise, can do to at least solve the pain related to network security. So Calico, as you probably know, is a community-driven project that is actually building open source networking and security solutions for mostly containers, but it can also work on virtual machines and host-based workloads. And in the topic of today, this might be important. We're not only talking about security in containers, but as well as security of the host, so the host or the VMs on which your Kubernetes cluster is running. So small side remark on this. Why Calico? Calico has been there for quite some time. The true added value of Calico is that it's very fast data plane based on layer 3. Which basically means that it is based or can be based on routing, and you do not need any encapsulation. From a security point, that might be an advantage for sure if you have monitoring tools on the underlying network. But in general, mostly this is encapsulated, so pretty invisible for external tools to Kubernetes. It's massively scalable, so that means we can have hundreds and hundreds of clusters. Most cloud providers already adopted the Calico network security policy mechanism, as well as some of them can be used with the Calico CNI, so the networking part. There are quite a lot of additions which are actually using Calico, whether it's Docker Enterprise, Rancher, Nutanix is using it, VMware is using it, and so on and so forth. So if you're looking for a stable and known CNI and security solution, well, Calico is a good way forward. We're used in one of the biggest, or used in the biggest companies around here. So we must have more than 1 million nodes that we know of. So as I already mentioned, Calico is an industry standard for most environments towards Kubernetes network security. We already covered that. But interesting to know is that since we're living more and more multi-cloud environments, so that also means that you want to have one single pane, one management console to actually monitor and deploy your security policies. Through use of Calico and APIs, you can actually do that so that you can actually have one environment from which you manage your security policies. Okay, so let's discuss a little bit Kubernetes and the security problems that surround it. And it's always a good way to think about it in sense of a threat matrix. What are the threats? Because we tend to lose when we talk about products or solutions, they typically focus on specific use case or specific environment or specific topic. And Kubernetes security is a way broader topic than just network or containers or pods or something like that. So I did some searching around, and one good way to start off if you want to actually analyze the security risks associated with Kubernetes is to take a look at mitre.org. Basically, it's a free-to-use tool and information that you can actually use to better understand the attack surface of your environment. It's not related to Kubernetes at all. It's more related to Linux, Windows, and so on and so forth. It's more broader, but it gives you a good idea about what to look at when we're talking about protecting Kubernetes and the environment. So it's a good thing and a must to have to understand the attack surface. It's not only containers, it's Kubernetes itself, it's the network, it's the firewalls in front of it, it's the application, and so on and so forth. So protecting Kubernetes and applications at the end of the day running on top of Kubernetes is a challenging job. The attack framework also tries to explain the tactics and the techniques used by attackers to gain access. I'm not going to read them all, but at the end of the day, attackers, they don't have an easy job. It's not just running a script and you have access. So if you have to, or if an attacker wants to breach actually a system, well, it has to do a lot of reconnaissance. Yeah. Once he gets in by a little port or a little bug, he needs to try and escalate his privilege so that he can actually access resources which are more valuable. Quite often, high valuable targets are well protected, but maybe through means of a small bug, he might access a cluster. From that cluster, he might actually have an easy way into the crown jewels, as we tend to call them. Another thing which is pretty important is once you gain access, an attacker also needs to make sure that he can actually get what he wants to have, but he also have to get the stuff out. If he wants to steal credentials, well, he needs to make sure that he can get the credentials out. So typically it means sending out twin HTTP curls, reverse backdoors, other kind of tools that might copy data. So it needs to have a channel back out. And once more, quite often, a lot of applications or containers or pods or images that you actually download from the internet, when they are actually being infected by malware, quite often you have command and control channels and so on and so forth to do that. So knowing all this is nothing new. This problem existed when you basically had an old Windows server with a website. We move to Kubernetes, it just becomes more complex. These problems don't go away from insecure applications, insecure networks. now we actually add Docker and Kubernetes on top of it to make it a little bit more complex. So always a good thing to step behind and try to understand, okay, which are all the attack surfaces I'm facing, because you might not always be responsible for all of them. There are a few cool projects that I think is worth mentioning. There is one which is in progress. It's very early, but it's a project about pen testing and testing Kubernetes. I think it's very valuable, but it's a small project that's going on. The one which is way more advanced is the Docker Top 10, which in the context of Kubernetes will only cover, of course, a smaller part, but it's way more focused towards containers and the threats associated with containers. So I urge you to actually go and check this out. It's written by a Belgian guy, not me, but for me, it's cool to know. So check out these pages. It might contain very useful information. Now, while searching through Google, I found a very interesting blog, a very recent one from Microsoft, and they actually took the Mitigation attack framework, and at some degree they translated it into actually a threat matrix for Kubernetes, which I think is a good thing to do, so that we can better understand if we have a Kubernetes or container mindset to understand what is a possible problem. It's very well documented, so I encourage you to read it. It's not that long. It's a very good thing to read. Now, what I tried to do is actually, as already stated, Calico or Calico Enterprise is not going to solve the entire problem you might have with Kubernetes and applications. It will solve specific problems very well, but others it will not solve or protect against, while other products will probably solve some other problems while not protecting the network in a decent way. So what I try to do is somehow highlight where Calico can be of use, where it can probably solve most of your problems, or at least your problems partially. So if we look at the threat matrix, first of all, in the first phase, an attacker will try to actually get access to the cluster. Now, there are ways to do that, too much, honestly. Very often we have exposed dashboards. I think about the Kubernetes web dashboard. Quite often it is installed. I've seen multiple clouds or managed cloud services where it is actually exposed on the internet. So it's something to take into account. Application vulnerabilities. Calico itself will not protect against an application vulnerability as such, but it's an ideal tool to shield off an application from the internet or from certain services inside your cluster. And it might help drastically when an application is breached to prevent somebody from leaving from that container or from that application back to the internet towards another system or environment. Same, once they get in, problem is they're going to try to build backdoors. Yeah? So they're going to try to do remote code execution on applications. And although I'm the first one to say that applications should be secure and you should not be able to actually run code or execute code remotely, well, there is always the problem of 0 days that with all best intentions are very hard to stop. Once there is a 0 day, and there is a remote code execution, well, hackers can actually try to launch connections or actually try to do privilege escalation to make sure they can jump from one service to another. Same thing for the SSH service. I looked into it a while ago. It's perfectly possible to actually connect from a pod to the SSH service on the VMs. On the other side, it's also perfectly possible to SSH into a server and jump to a pod. So it's not only through kubectl or the kube API interface that you might try to access applications. You could also do it through SSH. As I already mentioned, Calico can have controls that are running on the host that actually hosts your Kubernetes. Well, it might also be the ideal place to implement security policy, network security policies, so that you can only SSH into the service and harden, of course, the SSH service. So backdoor containers, it's a big problem. There is a tool running around on the internet, it's called Docker Scan. It allows you to backdoor a container. I've tried and scanned it with very expensive tools, and up to now, I didn't find any tool that would actually detect it. So backdoor containers might be a very big problem, which means that once you have the backdoor installed, hackers have basically free access inside of your cluster. Privilege escalation, very often overlooked. But when we talk about privilege escalation and we talk about access cloud resources, there's something to take count of when we actually use Kubernetes. And it's integrated with a cloud, or we're using AKS or EKS or whatever managed cloud service. Through kubectl or the kube API service, you can actually create load balancers. You can actually configure quite often the network resources. A lot of Kubernetes clusters have access to cloud resources, which basically means that Kubernetes is capable in some cases to actually configure something inside of your cloud. Think about it. If your Kubernetes cluster gets breached, somebody might find these credentials and actually change stuff inside of your cloud. We did a webinar a few weeks ago about AKS. I didn't follow over it, but actually when you install AKS, well, you have to create a service principal, which is actually a resource that can configure the cloud. So think about it, where is it stored on top of your Kubernetes or your VMs? There are a lot of other mechanisms that we might use to basically evade problems. But one thing I actually want to highlight here is also the discovery phase. And this is something where Calico and Calico Enterprise can help you immensely. We'll discuss it more in depth, but once you have access on a Kubernetes cluster through a pod, well, you actually have access to the entire network, but also to the nodes, as well as to the API service. So think about it, it's a very important point. Lateral movement is a name that actually captures what if I get into a pod. Well, in Kubernetes, it's pretty simple to move from one pod to another pod, from one namespace to another namespace. And last but not least, if we have impact, what can we do? There are a lot of things you can do, of course, when you have access to a cluster. One that is more related to Calico is denial of service. So a lot of problems to look at, and it would be a little bit exaggerated if I would say I can solve them all, and we can solve them all with Calico. But I hope this is a good entry point to think about all the possible threats. That's where there's a threat matrix in order to solve the problem. Now, something which is not covered in that threat matrix, although it is somewhere inside of the different blocks, is that once you get access, once an attacker gets access, yeah, it's very important for him to basically bypass all the threats and establish a command and control channel so that he can get in and out of the cluster very easily, as well as exfiltrate data. It means that if I can steal credentials, I need to make sure I get credentials out of it. So if the demo works, I'll show that, a very neat trick to do that. But it's important because blocking command and control channels might look easy, but malware is using very advanced techniques like domain generation algorithms to basically make sure that it goes out undetected. Now, if you look at the Kubernetes attack surface, well, as I already mentioned, there are a few things to look at. So you know, there is a cluster. Cluster is made of nodes, of course. And one of the most important parts inside of the cluster is, of course, the master machines, which are running the etcd database. The etcd database is basically the data store that actually has all the information about the state and configuration of your cluster. So access to that etcd database is fairly important. And if we look in the documentation, it basically says that the only one to actually access the etcd database should be the Kube API server, which in practice is not very often the case. It's authenticated, I agree, but as you will see in quite a lot of cases, the etcd database is from a networking point of view accessible from the network. So very important to check what services of your control plane and your master are accessible, whether or not you can actually intercept traffic to the control plane, meaning hackers might be capable of intercepting your Kube API traffic if you're not careful with certificates and validation of automation scripts, for example. It might be very easy for an attacker to intercept actually access to your Kubernetes cluster, which, as you probably understand, a very painful scenario to have. Other ways that we might have problems is with the inter-node communication. If you look into the Kubernetes documentation, you might think that the master nodes are the only one to connect to the nodes, or that the nodes are the only ones to connect to the Kubernetes masters. Very often, this is not the case, and these kubelet nodes are also very often accessible across the internet. So a lot of points to look at, and this is only from a networking perspective. Last but not least, on top of our nodes, we're going to run pods and containers and applications. So quite often an easy and way into a cluster is through an application. This problem exists already for 20, 30, 40 years. Well, the problem did not go away. On the counter, applications are more and more getting complex. They have more functionality. So an easy way into an application, and forgetting about container security best practices and Kubernetes best practices, might have very severe impacts. Now, I amused myself a while back creating this animation, and to better understand the attack surface from a networking point of view, well, think about this. Imagine that we have a web server running on top of our Kubernetes environment. What typically happens is that a connection comes in through a firewall or a router, and at that level, in most of the cases, let's consider it underlay, meaning that at DNS level, at IP level, we're actually targeting probably an external load balancer. So that means that from a Kubernetes awareness at this point, there is little or no visibility. Now, that load balancer, as I already pointed out, is probably configured through Kubernetes, through a load balancing service or some advanced annotations. So that load balancing device or software is capable of knowing where to send the traffic to. This is happening through node ports, and the node ports on a specific Kubernetes node is actually directing to a web server. This is how the network works, but at the end of the day, the hacker who's sitting outside right now talks to port 443 or port 80 on that web server. Microservices, the idea behind microservices is that they're very tiny services that talk to other services. Well, inside of Kubernetes, the way to do that is that one service talks to another service over an overlay or routed, whatever environment you're using. Calico is very often routed, but you have Flannel, which is typically an overlay. So that's how they communicate. So think about it, the way that pods can actually talk to each other. There are small, subtle differences. Very often this is pod to service, which basically means that the web server in this case has no idea what the IP addresses are of the Node.js in this case. So it actually sends it to a cluster IP address. And that cluster IP address is a construct in Kubernetes that knows what Node.js services are there. The reason this is the case is because of the dynamic nature of Kubernetes. You don't know which IP address is doing what. You don't know which IP address is the web server. Yeah. If you think about intrusion detection and prevention systems, they have exactly the same problem. They see an IP address, but since that IP address is dynamic, it's very hard to know, is this a web server or not? Yeah. Pods can talk to each other through the services idea, but pods can also connect directly to another pod. If you know the IP address of a pod, yeah, you can connect to it. So think about it, the free game scanners or network scanners have once they are inside Kubernetes. Yeah? By default, whether it's Calico or some other solution, by default, nothing is preventing a pod to talk to another pod. That's why Calico implements network security policies in an advanced way so that you can actually limit which pods can talk to which pods through the idea of namespaces. So pod to service is possible, pod to pod is possible, and something which is often forgotten, it's not because an application sits in namespace 1 and another application is sitting in namespace 2. Nothing is preventing a pod in namespace 1 to talk to a pod in namespace 2. So if you have like 10 namespaces, or you have like a production namespace and you have a development namespace, nothing prevents that both talk to each other unless you implement security policies, of course, or use different clusters. So a good understanding on how your networking is happening inside of Kubernetes is already a very good step forward. That's why Calico has a lot of tools like Calico CTL. It's easy, you can segment and so on and so forth. So understanding, monitoring, and troubleshooting your Kubernetes networks through Calico is already a good step to take. Now, another thing I want to point out is that if a hacker comes in and he gains access to, for example, a pod, most pods also have access to the Kubernetes or the kubelet or the Kubernetes APIs. It's often overlooked, and I'll try to show it here in a demo later on. But if a pod is breached, that pod can try to access Kubernetes services. So it's an important thing to look at. And for what I know, I never found a good reason why this is the case, except if you have pods that interact with Kube API for monitoring, for security, or whatever. But always take into account that any pod, although with limited privileges, can access the Kube API. And these limits are higher than if you wouldn't have the account. So a pod with high privileges or a service account included with can have very drastic results. Also, just think about it. Very often, all the communications from the internet, at least towards the load balancer, are encrypted. So that also means that it probably goes undetected before it hits the Kubernetes cluster. I mentioned web application firewalls here. I've hardly seen it for Kubernetes because it seems to be very difficult to configure web application firewalls or NG firewalls at that level to basically correctly protect these applications. So think about it. There's a lot of stuff that might happen if a container gets breached. Last but not least, if you have access to a container, that container very often can access the internet, which is pretty cool from an attacker's point of view, because it's a way out, so it can exfiltrate data and so forth, and can control, for example, reverse shells inside of your cluster. So something to take care of. Also, please know that in 99% of the cases, traffic that is leaving the clusters are actually address translated on the Kubernetes nodes. So that means that once outside of a cluster, it becomes immensely expensive and difficult to actually track which pod originated the problem. And also becomes very complicated to block it outside of the cluster. To conclude this story, we often think that the way into the cluster is through a router, firewall, load balancing, and so on towards an application. But if you scan certain public clouds or Kubernetes cluster, you'll probably also find the Kube API or other services which are available on the internet. So one way into the cluster might be through the Kube APIs. So also make sure that these access points are filtered when you deploy something securely. So once we go to the application attack surface, which is not core business of Tagira, but I just added it for completeness. There are a lot of tools, open source, commercial tools, and so on and so forth, that actually go for container or scan container images for vulnerabilities. These tools are necessary. There are too many vulnerabilities around. But as I said before, image scanning is something that happens typically at build time of container images. So there is a time span between building and going into production. It's only scanning for known vulnerabilities. So 0 days go undetected. So it's a good first step to augment the security level, but it's not complete. Yeah. You can take additional measures to do, for example, dynamic or even static application security testing. But again, this is something which is very hard to do in Kubernetes when an application is live, because it's very heavy to it's very difficult to patch an application once it is deployed inside of Kubernetes. So when you detect something, you need to actually go through the entire life cycle of the application, probably pass through CI/CD to patch, scan, and so on and so forth until you have an image. All these things are very good practices to do, but there's always the notion of time pressure to go on. So bottom line is that we still find a lot of applications which are insecure or contain even known vulnerabilities. Now, where can Calico come in? I mentioned Calico Enterprise Edition. Some are available in Calico, some are available in Calico Enterprise Edition. And you should look at Calico Enterprise as, or Calico itself, as what we typically call runtime protection. Runtime protection is a broader topic than only Calico, but Calico is something which can help you when pods or applications are in production. So it's not during the build phase of an application, but really when you go live. So it means that at this point, we're going to implement mechanisms to prevent certain breaches, or at least from a breach to actually spread across the network. Yeah, so quarantining, making sure something is isolated. And this is really what Calico is made for. We already had quite a lot of sessions in the past, and there are a few, and most of them are online. So I'm not going to spin too deep in ingress and egress policies, but at the end of the day, Calico has a very broad tool set to actually create network security policies that protect data or traffic from flowing into pods, ingress, and very important, certainly in this topic, egress policies, which basically means what is allowed to actually exit a pod or a Kubernetes cluster. So I repeat myself probably, but when we talk about ingress and egress policies here, think about data plane movements, so in between, let's say, application pods, east-west, or even north-south, so communications. But don't forget, please, the Kubernetes control plane, as well as the access to the cloud resources. Very often this is unprotected because we don't know, or because it's different for Azure, AKS, DigitalOcean, whatever there is around. So think about it, because most cloud environments do have these metadata APIs, for example, to get an IP address or to configure a load balancer. Yeah. We can get quite some help with global threat feeds, open source or licensed one. And something I always stress since I think it's 30 years, I mean, firewalls are cool because it created visibility, logging, and alerts. And they always say history repeats itself, but when actually Kubernetes came along and networking, it's a lot of connections, a lot of data. So the first thing to forget was logging, which basically makes networking inside of Kubernetes light. So luckily we have Calico and Calico Enterprise to solve that problem. And believe me, when you see the logging, you probably get surprised by what you see happening. So just a few screenshots, but as I mentioned, we support global threat feeds based on domain name sets. So you can actually download, or Calico Enterprise can download a list of blacklisted domains. The blacklisted domain, there's a feature to block them, but the idea is that we have a list of domains that are actually blacklisted, as the name suggests, so that if a pod connects to one of these domains, you get alerts. So you get advertised that pods are possibly connecting to malicious domains. If you want to block it, you can, of course. But the idea here is that based on these domain name sets, you can actually have alerting going off. Another one I find interesting is, for example, this is an example where we actually import the Tor exit or Tor bullock exit list. I'm not against Tor. I find it very cool, but at the end of the day, from a security point of view, it might not be the best thing to allow in because it's basically anonymizing traffic. If it is used for good purpose, fine, but it's probably also used for bad purposes, which is not so good. So if you have applications where you really do not want, for example, Tor exit points to connect, well, you can actually create policies that say not to connect or not to use these environments. For this kind of IP-based listing, we can actually also create a global network set. Global network set is something you can actually create in Calico as well as in Calico Enterprise, so that based on what is inside of these lists, you can actually block or allow traffic. Calico Enterprise allows you to actually pull the thread feed and convert it into the network set. If not, you have to do it manually. That's for the YAML. Of course, all this stuff is logged and alerted. So it's always good to take a look at it. We use Prometheus, we use Elastic and so on and so forth. So it's very flexible and at least customizable to send alerts in different ways to different. So that's from a prevention thing. These are things you can actually say, okay, I'm going to block this and so on and so forth. Another area where Calico is pretty busy with intensively, and we're going to launch quite a lot of stuff, is about the logging, metrics, machine learning, and so on and so forth. So I'm going to show this in the demo. So that's always nicer than just some bunch of text. But before I do the demo, a few words on domain name generation. I'll show this. These are the anomaly detections which are built into Calico, so it will tell you whether there's a ping flood or whatever going on. But a few words about domain name generation. Remember, I said in the beginning that it's very important for a hacker to actually create an outbound channel to extract the data. He needs to send it to somewhere. If there is malware, it needs to connect to something. Well, very often it's using DNS or static IP address, but that's pretty easy to block. If somebody knows the domain name, you can very easily block it. So they came actually up with what is called domain generation algorithm. So it's generating a whole bunch of freaky domains like the one you see here. So what hackers do is they register a few of these crazy looking domain names behind which they hide their control servers. So based on how do these malwares work, so what they basically do is there's an algorithm behind it to generate them. That can be based on the time of day of the month, a date or whatever. So malware can actually generate a bunch of these domains, and it actually just tests whether these domains are registered or not, if there is a DNS record behind it or not. So based, for example, on the day, they can calculate the possible DNS names and use that to connect. So it's very hard to predict which domain it is, so it becomes rather impossible to actually blacklist or block it. So it's not that easy to write this kind of thing. If you search for a domain generation algorithm on Wikipedia, you find like 4 or 5 lines of Python code, which can actually generate this. So it's pretty easy to do. The downside is it's very difficult to detect. So because of the detection challenge, some smart guys at Tagira, they actually developed a machine learning algorithm to actually go and find these generated domains. And at this point, the latest tests we've been doing, and if you search for it on Google, you'll find them. You can share it if you want later on. There is a nice webinar available showing it live and so on and so forth. But through machine learning, I'm not saying it's easy, but it's easy to use, yeah, and detect these anomalies with a pretty high confidence. So logging, creating visibility is one thing, but actually using all this logging information and use it afterwards to actually go and detect these kind of problems is pretty cool. Yeah. If Calico Enterprise detects these kinds of randomly generated domain names, well, it will issue alerts and potentially block it. I didn't verify this, but these are actually malware families we tested against the algorithm, and we had pretty good results in detecting the domain name generation. So if you want to play around with Calico Enterprise and what you're going to see in the demo, go to tagira.io/trial, and you can actually go and ask for an environment to play around with. So you can actually enjoy and use and get used to the troubleshooting tools and logging and so on and so forth. So please feel free to do that. Also, please check out the upcoming events and also sign up for the events so that you get alerted whenever there is something new we're going to present. So time enough on slides. I'm going to switch to my first move. So I'm inside of Calico Enterprise. So Calico Enterprise has a user interface, so it will show you all the policies, how many packets, connections, and so on and so forth are happening. So always good to have an idea how many policies, how many protected nodes, unprotected nodes for sure when we talk about intrusion prevention. Yeah, all pretty cool stuff. One thing which is not the most fancy thing to show, but I find it incredibly important to have it, is Calico can fairly easily create an inventory of all the pods, machines, and so on and so forth that are running inside of your Kubernetes cluster. Now, all this information, of course, is available through JSON files and so on and so forth, because that's what the interface is using. So if you need to create lists, if you need to have mappings between a pod name and an IP address, well, this information is very easily available throughout the API. And for example, if you want to do an automatic blocking for something, you can actually get that information out of it. More on that if you want later on. So next thing is visualization of flows. We have a very cool thing which is called Flow Visualizer. Not going to spend too much time in it, but it's a way to actually go and analyze who is talking to who in a very graphical way. You can actually see which policies are applied, which policies are not applied, whether it's protected or not. And if traffic would be blocked, you would actually see it as red flashing. So it's the first way to actually see whether something is blocked. But let's say this is a graphical thing. If you want to know all the details, well, one of the most important things that Calico Enterprise does for you is that you can, no, that was the wrong button. is that you can actually go inside Calico Enterprise, and when it loads, we can actually see a summary of all the flows. This is very detailed, all the logging. You can even see the raw logging, so that you can actually say, okay, show me the traffic that, for example, this pod has been doing. So you can actually see which pods are talking to which pods, what labels, what policies are implemented, and so on and so forth. So think about this. There is an Elasticsearch database behind it that has all the logging information available. Yeah. So we have that bunch of data available right now. So if somebody launches, I see a message popping up. Yeah, and Jane already answered it. Cool. So we have all this information available at this point. But if you have millions of logs, you're probably reacting exactly the same as I would. How the heck do I have to search through all these logs? That's why, based on these logs, we can aggregate them and we can summarize them and so on and so forth. I already loaded it, but what Tagira Enterprise can do is actually use that data and use machine learning techniques like the one for the domain generation algorithm and for other, and we can actually run it. As you see, this one is open, so it's running all of the time. So it's continuously analyzing all the log feeds that come in. Yeah. And based on these log feeds, it will, in this case, scan for port scans. It can scan for IP sweeps. It's extensible, of course. It can actually detect spikes in traffic and so on and so forth. So based on all the logs that actually flow into the system, we can actually launch anomaly detection jobs so that we can actually generate alerts. Because think of it, we might actually ask the question, can you stop a port scan? Yes, you can stop a port scan, but the problem is that you can only stop a port scan when you see that it is scanning a lot of ports. So don't get confused that a lot of these things might at first look very easy to detect and block, but essentially it's not true. So these anomaly detection jobs, they can run continuously or they can run at specific intervals. And once they detect something, they can actually go inside of the dashboard here. And if the dashboard is loaded, you can actually see that I already did a few of these scans and so on and so forth, but that it can actually say that, okay, I've seen a pod called Hacker, which was actually doing a port scan. And how did it detect it? Because it's pretty cool. It's not because it detected a pod that was actually doing a scan or that it detected it was running Nmap, but it actually, maybe I can show this quickly. If you go in Anomaly Explorer, for example, and you search for the scanner that I launched, you can actually see that it's pretty cool because based on the average connections, based on what it sees about the spikiness, so it does quite a lot of cool stuff, you can actually see that the behavior of that scanner was 100 times higher than what we typically see for other pods in the cluster. So it's not simply saying, okay, it scanned from port 1, 2, 3, 4, 5, 6. Yeah, it actually analyzed the amount of traffic it sent, how much the ports are distributed, how much the IP addresses are distributed. So it can actually distinguish between a port scan and an IP sweeping of your cluster. So all that information is mounted up. You can find it back and so on and so forth. These are the things I talked about earlier. So if somebody uses a Tor exit point, well, you get alerts and so on and so forth. Last but not least, We also have compliance reporting. As I mentioned, it's important to know the changes, to know the state of the cluster. So you can actually use compliance reporting inside of Kubernetes to actually see how the state of your cluster changed, or to actually see whether your resources are still protected or not. So these are pretty easy to add to the system, and it gives you a graphical overview of what is going on. So last but not least, a small fun thing. If you want to play around at a given point. Well, so while I was preparing for this, I actually asked myself the question, how long would it actually take to scan clusters? Well, I was a little bit surprised to see that it really doesn't take that long to. So let me just, I have access to this cluster. I'm going to just spin up a pod. So to show you, this is a simple pod. It's not privileged, it's no nothing. And just to basically show you a few things we mentioned is that, first of all—
Hey, can you make the font a little bit bigger, please? Thank you.
Please. Better? So, as I mentioned, I'm going to show you a few things. I mentioned that pods do have access to the Kube API, limited privileges. And when you read the documentation, they say it's stored in secrets, and secrets are securely mounted into pods. But where's the secret inside of the pod? Well, I have news. If you do cut to this URL, you find the default token. If a hacker has access to a pod and he does want to know in which namespace he's sitting, which might be interesting information, well, that information is actually available in the pod. As you can see, this one is running in default. So think about if you have an application vulnerability and the hacker can read the file system of the pod, well, it already has some interesting information. Yeah. Now, if you want to dig deeper to see what you can actually do if you have a pod, in the first phase, I would be interested in actually knowing where the DNS, what are the names, the networks and stuff and so on. And it's no rocket science. Yeah, it's been the case for a very long time, but also a pod has a conf resolve file, and we already know the name servers. And another cool thing to know is the domain or the naming of the domains inside of Kubernetes. Yeah. This is all information I got from a simple pod. Yeah. So if I want to dig deeper, I can actually use things like a simple dig or an NSLOOKUP, and I can actually find fairly easily, although this is a known IP address, the IP address of the Kubernetes API. I can do something similar to find the DNS IP addresses of the cluster and so on and so forth. So at this point, I have a first idea about what are actually the services or the service side ranges. If I do IP address -A, I actually also know, probably fairly easy to guess, the pod size. So doing that information allows a hacker to actually start investigating more in depth. And I actually did this test. I'm not going to leave it running, but by running an nmap ping scan and tune it a little bit, because we could expect expect the round trip to be fairly small inside of the cluster. It took me around 3-4 minutes to scan the entire /16 range, which is pretty fast. That means that if a pod at this point is not protected with a network security policy, in a few minutes, I'll probably have all the IP addresses of pods inside of the cluster, yeah, with simple old school hacking tools. Don't know where we are, but it takes a while. So believe me, if we wait for a few seconds, we will get them. I've tried other scenarios and used more advanced scanning techniques, which would be even harder to detect. So if I use port 80.443, 8080, and so on and so forth, I could use 9000. Well, I can also fairly easily and very fast identify all the hosts inside of the Kubernetes cluster. So don't think because it's running inside of a pod that these mechanisms really do not work. Honestly, the reasons why you saw the alerts inside of the enterprise version was because I run exactly the same scans. Okay. I'm scanning, in this case, honestly, the pods or the pod networks, but if I would do something like this, you see how fast it went. I'm actually scanning, you see this IP address, which is actually the node IP address. So from inside of a pod, you can fairly quickly scan the node on which it is sitting, or any other node, probably. Don't mind the naming, because Nmap is not up to date with Kubernetes, but as you can see, I found the API for the UI, I found the Kubernetes API, I found the etcd service, and so on and so forth. So it's not incredibly difficult for a hacker to obtain information on your cluster. Now, last but not least, I find it a very cool trick. Of course, I can curl to the internet from this pod. Yeah, so I have access to the internet. But still, I was looking at it. Why would you block specific APIs? Why is it worthwhile monitoring APIs and so on and so forth? So I came across a nice trick, which I'm going to copy paste here. And it gives me a lot of things. But what it actually did was, if I open Slack here, and I go to my, let me see, Slack window here, you can actually see that by using Slack APIs, I can actually transfer files out of my Kubernetes cluster, which is pretty cool. This means that a hacker doesn't even have to install tools or remote shells. By just issuing curl commands, or through any other means, it will probably also work. You can actually transfer files outside of a Kubernetes cluster, including an example I tried earlier is by, if I go back, to actually send out the service account tokens. So imagine that this will be happening inside of a privileged pod, or a pod that is talking to the Kube API server. Well, that would mean that I would have the token and that I could actually initiate from outside of the cluster connections to the API server. So I want to conclude this session by actually saying that for sure, you cannot solve all the problems related to security with Calico. But on the other hand, Calico and Calico Enterprise will provide you the visibility, tools, the troubleshooting, and the analyzing tools to actually understand what is happening from a networking point of view inside of your clusters. Based on analyzing the logging, you might find pods that are actually behaving weirdly based on behavior. So I hope it was interesting. It was no means of covering every potential attack inside of Kubernetes, but to focus on what we could actually solve by using Calico. So I thank you. I'll see if there are a few questions left I can answer. Yes, we can see denial logs. I think I already replied to that. Does Calico have IDS, IPS? So there are few IPS, IDS features in it that can instantly block. We have the machine learning to actually see weird or weird behavior. Something I didn't cover, but we'll have more information soon, is we're building a kind of honeypot. I've seen a proof of concept of it. So you will be able to deploy kind of honeypot inside of Tigera so that we can have a way faster and higher accuracy in detecting malicious connections and initiate blocking. But that's something we're working on. And if you really want to see it, I'm sure our guys can show it. I think that's more or less it. So I thank you for attending. I hope it was interesting and hope to see you soon in one of our next sessions. Thank you. See you.